Okay, hello everyone. Welcome to our weekly API work group meeting. We've got a couple of topics to go through. One thing I'll point out before we start is there is an actions markdown page on the OPI site. I've been collecting some of the questions and outstanding things that we have there, so we can start keeping track of those. And if we want to start answering them, we can just go ahead and update the markdown file as we get through them. But we'll come back and revisit those over time. So for today, we've got a couple of things on the agenda. The first one was we were going to get a summary readout on the storage backend discussion. I think Vipin and Ben, and Boris have had a long discussion going on the storage channel on Slack. And they've been talking about some backend changes. So if we wanted to get into that, we can start that one, and then following that, we'll do a detailed API walkthrough for the IPU POC demo that was given by Intel and Ericsson. So with that, Vipin, Ben, Boris, do you guys have a summary for the backend storage discussion, or did you still need more time on that?
I can summarize it for everyone, and then what I was mentioning was that we will have some more discussion, and maybe next meeting I can describe a few more things with the diagrams as to what exactly the contention points are. But basically we are agreeing on things like, we need to address multipathing in NVMe, we need in backend definitions and all, just so that we could leverage the redundancy in the network available towards the backend. We both see the need for decoupling the current structure to be split so that the path information, the target endpoint information is separated from the controller information. So there is good agreement there. I'm sensing there is no objection to including source port information as well in the backend information. But the main discussion or contention point really is whether we have separate objects for endpoints, which is port and IP address information for both source and destination, or couple that in the path itself. As in, do we define a path object that includes everything related to a path in one place, or do we split that into two objects? The first one being the one that defines the endpoint, which is IP and port, and the second one that defines the path that includes that endpoint information in it. So that's the main contention point. Ben is asking for justification for why I feel that these two objects be separate, whereas his feeling is that it should be one object because it's less confusing to the user, and it's simpler. Everything is like encapsulated in at one place, and then my reason for doing that was to help with the distributed backend, but like I said, I will have some more pictures to describe why I feel that could be useful, and then we can decide.
Okay, you want me to key that up for next week still?
Yeah. So I will probably need like 10 and 15 minutes for on it next week.
Okay, that sounds good. Thanks, Vipin. Thanks for the update.
Yeah, but just to update everyone, this is where we are right now. So most likely we will update the backend APIs. There are a few things that are pending, but yeah.
Okay, great. All
Ben,
right.
you can, if Ben is here, you can correct me, Ben.
Yeah, I hadn't seen Ben.
Boris, is Boris here?
Boris is here, yeah.
I'm here.
Oh, okay. Yeah, feel free to add Boris, because I thought I captured it well from from both sides of our our discussions.
No, you did a good summary. So yeah, basically the work on the backend APIs, what we're doing, and currently we trying to split the existing objects into more granular to accommodate multipathing. So yeah, you summarized it really good.
Thanks.
Okay. So that'll allow us to move to the detailed API walkthrough.
Just the last thing, Mark, before we continue.
Sure.
As we promised last week, we opened the window for quality of service pull request of 1
Oh,
week.
you're right. Thanks, Boris. I forgot about that. Yeah, we do have the window for the quality of service pull request that's going on out there.
So it's ended today, and we need to decide if we merge in that.
Right. So were there any outstanding comments that hadn't been incorporated yet? I didn't look at it as of this morning. Let me check it right now. Let's see.
I think we convinced Vipin that the PR looks good, right, Vipin?
Yeah, I'm good with it.
Yeah, nobody else commented, so
Yep.
I moved to a vote to merge this pull request as is, unless somebody objects on the meeting.
Yep. Any objections from the meeting as to whether we merge this in?
I really encourage other vendors to look at the pull requests that we produce, and even if you agreeing, we need kind of affirmative agreement on the pull request for documentation purposes. If you're not looking in that, I see only Vipin commented. Intel suggested the pull request, so that's fine. So not sure who represents NVIDIA here.
Yeah, just Vipin's is the only comments that have been in there, Boris.
Yeah, so Marvell need to be more vocal, and NVIDIA. I saw Noam previously, now he dropped. Okay.
Well, if there's no additional comments, we'll go ahead and get this one approved and merged it in. Okay. We'll close that one out. Awesome. Thanks, Boris. I had it on a different list, but I didn't have my right list pulled up. Okay, so let's move to the detailed API walkthrough. This was from the IP POC demo that we had the other day. So if we can go ahead and bring that PR up. If you would like me to, I can share it, or how do you want to handle that?
I have like a short presentation first, just to give a background, and then we can go to the
That would be
walkthrough of the PR. Is that okay?
That'd be perfect. Thank you.
Okay. Let me share my screen really quick. Are you able to see the slides?
It came up for a second and it went to there it is.
Okay. So I'm not sure if you remember, but and if you have participated in that meeting, but in the past we have joined in the use case, OPI use case group meeting, in order to present the joint POC that we are doing with Intel, between Intel and Ericsson, and it is based on the IPU. So as an artifact of this POC is the API that we have designed for XPUs, and it is called EVPN Gateway API, because through that API we offload the whole EVPN EVPN gateway directly on the XPU SmartNIC. So just let's discuss a bit about an overview. In the first slide, so the VPN Gateway API, it is based on the EVPN protocol for layer 2, layer 3 VPNs. The initial design is to support single/multi-server side deployments. It is designed to support Kubernetes primary, but most importantly, the accelerated secondary networking use case, which is a critical use case for telco industries. As I said, it acts as an integrated edge router, EVPN gateway on the XPU SmartNIC. And on the last two bullets, you can find the presentation and the hands-on demo that we have, the recording that we had on the OPI use case workgroup. And also on the last bullet, you can find the link with the pull request where the discussion has started. So just to say a few words around the network architecture. So in this slide, we can see a typical scenario that we would like to deploy. On the right-hand side, we have the green workloads, which are single server deployments for now. And a use case for those workloads could be Cloud Run or local packet gateway. So these workloads, they want to connect among themselves and also with the data center on the left-hand side. And what we assume is that in place there is an unknown transport network, which is IP capable. That means that it can actually transfer IP packets. So that means that we need to create an overlay over this underlay IP transport. And another requirement that we also have is that we need traffic separation. That means logical separation between logical networks, which is also increases security on that. And we have an additional requirement of overlapping IP addresses. And that dictates that we need some VPN technology that will serve those requirements. And you can see on the blue box that the ultimate goal is to optimize the standalone server deployments or small cluster deployments in an edge site. And we would like to avoid the extra cost for dedicated site network equipment and remove the dependencies on transport infrastructure. So the technology that we have chosen is the EVPN protocol. It is a standardized protocol by IETF, and it is heavily used in the data center today. And it allows to create layer 2 and layer 3 VPN overlays on top of the existing IP transport network, which is our underlay. So if we see the VPN protocol implementation in more detail, we can see that for the control plane, we use BGP session in order to exchange routes between the two sites. And also for the data plane, we are using a VXLAN tunnel for the encapsulation of the packets. And we have added also IPsec tunnel encapsulation, so all the traffic goes through the IPsec tunnel for security reasons. That means that we have an EVPN gateway implemented directly on the XPU on the right-hand side that can actually do that. So if we check the, sorry, is there a comment?
No.
Okay. So if we take a look on the Kubernetes networking and EVPN gateway design, just to give you an overview, at the top, we have our host, our workload server, where we have installed Kubernetes. And for primary networking, we're using Calico CNI and kubeproxy, where together with Linux routing IP tables, we plumb the typical ETH0 interfaces that devs in the Kubernetes pod. And we're using there a primary VF that comes from the XPU, and we're using that primary VF mostly for external connectivity in the primary networking use case. But the most important use case for us is the secondary part, where we have secondary virtual functions that are plumbed into the pods, and they can be access type or VLAN trunk type virtual functions, and they get in provision with the use of Multus and a new CNI that we are developing, which is called XPU CNI. So those secondary virtual functions inside the Kubernetes pod can actually access the physical port of the XPU through a programmable hardware pipeline where the whole EVPN gateway gets offloaded in different steps. That we have there the VLAN aware layer 2 bridge, the VRF routing, the VXLAN encapsulation, decapsulation, and then we have the underlay routing stage, and also the IPsec encryption decryption component. In order to configure with rules this hardware pipeline, we need a control plane. So on the left-hand side, on the ARM cores, we have a Linux bridging and routing control plane, and also we have an EVPN gateway control plane, which is based on the FRR. And we have also an IPsec control plane, which is based on the Strongs one. And in order to configure this control plane, we have an orchestration component that we call it XPU Infra Manager. So this component configures the control plane, and then it monitors the states of the control plane and translate that state to rules that is programmed in the hardware pipeline through a vendor specific plugin that sits on the XPU Infra Manager component. And also that this XPU Infra Manager component, a part of this vendor plugin, which is vendor specific, it's most of its code, most of its part is vendor agnostic. So you can easily develop, a vendor can easily develop its own plugin in order to configure its DPU, IPU. And then it comes to the network provisioning part, where on top of the XPU Infra Manager, we have the VPN Gateway gRPC API that we are going to present today. And through a network provisioning CLI and the XPU agent that sits inside XPU CNI, we can create networking objects in that API. More specifically, the XPU agent, it creates the appropriate networking object, which is bridge ports in our case, in order to configure correctly the networking part of the secondary virtual functions that we plumb into the Kubernetes pods. Here we can see the EVPN Gateway API that we are proposing. This is a lean API for EVPN orchestration, and we can start from the logical bridge component, which represent a layer 2 broadcast domain. And optionally, when we define a VNI, it can be a part of a layer 2 EVPN instance. So, in this logical bridge, we can have 0 more bridge ports, and a bridge port attaches a virtual function to one or more logical bridges, and a bridge port can be of type access or VLAN trunk port. Then we have on the left-hand side the VRF component, the VRF object, which represent the local routing instance of an L3 VPN when we define a layer 3 VNI. And also, in order to connect logical bridges to VRFs, we have defined the SVI, which stands for Switch Virtual Interface. Is there any questions so far? Because I would like to go to the protobuf files now.
Yes, Dmitry, so one question, as I posted in the chat, there are already defined models in OpenConfig for EVPN. So the question is how they correlate to what you're doing and why we're defining the new models.
I don't have an answer to that right now. I'm not aware of those OpenConfig instances, so I have to take a look, really, Boris.
Yeah, thanks. I posted in the chat. You can look at it.
Do you think that those OpenConfig APIs would be at a kind of higher layer than what we're trying to do here? Would that be true to say, Boris, do you think? Or
Sorry, John, come again?
do you think those OpenConfig APIs would be at a higher layer so that they might talk to the, the routing stack above, we'll say, our API and then translate from that to our API? Or do you think you could implement what we want to do with those OpenConfig APIs?
I haven't deep dived on those models. I just saw that they exist and I'm asking. We can always take the young models and auto-generate from them gRPC APIs and just use them as is instead of defining a new set of models.
Okay, let's have a look at it and see if we can,
And we can
resolve
add
the two.
system.
Yeah, I added a link in there to the actual OpenConfig doc, which talks about EVPN use cases.
Okay,
Go ahead,
we
Vipi.
can look at it.
So Dimitrios, thanks for describing the details. I'm really hoping that you can put some of these pictures in the PR itself in the description section. It will really help people understand the use case. But my question
Yeah,
was,
for sure, I will upload this picture. Oh, now it's a bit broken, but for sure I will upload this picture as Boris said, and
yeah,
maybe those two also,
correct.
if
Okay,
you think
so
they're interesting.
awesome. So my question was, on the slide on the use case scenario, where you were saying that enterprise branch or telco edge, enterprise side or telco edge would talk EVPN to the data center, which is happening across. Do you see this as part of the other side of the UPF function, or is this not related to that at all? Is purely within the data center?
It is kind of underneath the UPF function.
Okay.
Right? It's infrastructure. UPF would sit on top of this. It would run in the pods.
Yeah, UPF is an application in this server.
Yeah. So the offload of the application functionality to the XPU is a different question.
No. I wasn't talking about UPF offload. So I think you answered my question, which is that this is the mechanism using which UPF is going to talk to UPF, multiple instances of UPF or chain instance of UPF is going to talk to each other and or to the data center or
to the radio, to the data center, to central signaling entities.
Got it.
Like PTC.
Okay. Thanks.
Okay then. So if we go to the protobuf files, we really have two protobuf files for now. It is the layer 2, as we say, protobuf file, and the layer 3 protobuf file. Let's take a look on the layer 2 first. We start with the service, which is the logical bridge service, which we use to do operation when it comes to the logical bridge objects. So you have create logical bridge, list logical bridge, get logical bridge, and delete logical bridge. And the main object there that has really interest is the logical bridge info, where you can define the name, the VLAN ID that this logical bridge represents, and the VNI, which is optional, and you define that when you want your logical bridge to be connected to a layer 2 EVPN instance. And another service in this protobuf files is a bridgeport service, where you have again create, list, get, and delete bridgeport functions. And if we check the bridgeport info, we have the name there, we have the vport ID, which is a read-only ID that is assigned by the server during the creation of the bridge port internally. You have a MAC address field where you can define the MAC address of this bridge port, and you have a port type, which could be access when you are connected only to one logical bridge, only to one VLAN in an access way, and or a trunk when you want to have like a range of VLANs to access. And of course, the VLAN ID, which it is a repeated field, which means that when you have the trunk case, it will have like more than one VLANs there, and when you have the access case, it will have only one VLAN. Any question on this layer 2 protobuf?
Just a comment, I guess, and Vipin, we were looking at some of your, some of the comments that you put in. I think that you were associating, or you thought that, the bridge port and maybe the logical bridge could be, merged, we'll say, with the interfaces API that's currently in the cloud definitions. Whereas this really, from our perspective, I guess, is kind of about L2 bridging, right? It isn't necessarily, defining ports, we'll say, or interfaces. It's a different kind of a construct, if you like.
Well, I think it's a good observation, but the way I was thinking was that you define a subnet. A bridge is really a subnet with SVI enabled or not is still a different thing, but bridge is a logical network, or subnet is a good explanation of a bridged logical subnet, and where the forwarding happens based on the MAC address. And then if you have turned on routing, then you have SVI object that defines that, which could be, distributed routing, or, wherein at least the L3 VPN defines a way to do routing whereby every DPU could be a router on that particular router MAC and the router IP. So ignoring routing for a moment, logical bridge is what I was referring to as subnet, and the ports is where I was thinking would be interfaces. And again, like I mentioned in my comment in the PR, let's try and evolve these things first, and then maybe we come back to seeing what we can merge or how things are looking common separately. There is definitely a concept of multi-tenancy in cloud. There's concept of VXLAN in cloud. There's concept of VPC, which is WRF in the cloud. There's concept of subnets, which is which is what you're calling logical bridge. And then if you define a router interface on it, it becomes the SVI. So I see similarities, but yet I don't want to impose that we block this PR and work on merging these things. I think for now, or rather earlier, we agreed that let's try and evolve these things independently. And since this is V1 alpha for most of the APIs, build working prototypes so that we can come back and see, like, how do we combine these things, if at all. I don't know if I'm sense, but
yeah, no, that makes sense to me. Yeah,
awesome.
Yeah, seems fair. Yeah, I think it's probably a little bit early to try and combine these.
Correct. I think so too. Yeah, let's. And this is certainly an API most of the DPU vendors can implement, from what I see. So I mean, I can speak for Pensando and AMD. This is certainly implementable and looks quite reachable for us if the use case sounds interesting.
Yeah, and we, like you, I think, saw that there's definitely some overlap between, what you guys define as subnets and
there will be. I mean, networking inherently is like that. There will be there'll be routes and all that, but at logical level, and then once you get into the details, I think few things will differ, and the entities that call them are different. The settings is different. The environment in which it gets deployed is different. Like this is a Kubernetes deployment, which is different from the enterprise / data center Kubernetes deployment, where we are talking about the primary networking and integrating with CNI. So that's why I'm saying, like, let's keep them independent for now. I think it's better.
Okay.
Okay.
The only
there-
point I would like to add before we move on is that there is a conceptual difference between the subnet in the cloud model and the logical bridge here, because in our scenario, the logical bridge is explicitly an L2 bridge domain, meaning it is MAC forwarding, and it can carry anything, IP of course, but also other protocols, and that is actually essential in some contexts.
No, I recognize that.
Yes.
I totally recognize that. The point I was saying is that if you have not configured IP routing, and if even, I mean, this is something I'm saying that because we support that, at least in Pensando, we support bridging or for services today. And all you have to do is, don't send packet to a router MAC. That's all. And then it'll get bridged across VXLAN. So I really don't see that we need a new concept for that. If you have not enabled routing, this is exactly what happens in.
Yeah, but the point is creating a subnet implies somehow IP, and there are maybe
But
cases
you do
where that
have-
is
Correct. It does imply the concept of an IP subnet. I agree with that. But at the same time, you do want to route outside that subnet, outside that bridge domain as well. And then for that, if we are creating an SVI construct, then then that's okay. But I agree that it's probably the naming which is different. But like I'm suggesting in a subnet today, in any IP network and subnet today, if a VM or a host were to send a packet to another host on its MAC address, it will get bridged by the network. And if it is sent to the router MAC, then it'll get routed based on IP. I'm just following the simple mechanism that EVPN defines, or for that matter, it's been there for ages, how routing bridging works.
Yeah,
So,
I agree with you. But I also see that if the semantics of an API are not very well defined, then it is very hard to rely on them. And in Neutron, in OpenStack, for example, the semantic of a Neutron network was never really well defined. And in most implementations, L2 forwarding was working, but in some it wasn't. It was just emulating it and only for IP traffic. And I think we should not fall into that kind of trap.
Fair point. That's why I'm saying the subtleties are there. In fact, I was agreeing that there will be subtle differences, which is why, I'm not suggesting that we force merge these things right now at all. In fact, we should have deployments, and then we should come back and see where it makes sense to put them together. Yeah.
Okay.
Yeah. Thanks.
Okay, if there are not more points, then I will go to the layer 3
Someone
part.
has raised
So we have,
I thought someone raised their hand.
sorry, I cannot see the raised hands.
No, that's
But
it.
please go
Vipin-
ahead.
Yeah, Vipin, you're the only one with a raised hand right now.
Let me remove. Yeah.
Okay. Okay, so if we move on to the layer 3 protobuf file, the first service that we can see there is the VRF service, which is used in order to do operations on VRFs. So you have create, list, get, and delete VRF operations. And if we go to the VRF info object, we can see that we have a name there. We can define a VNI if we want this VRF to be part of a layer 3 VPN instance. We have also a routing table a field there which defaults to the VNI number that we define when we use a layer 3 VPN. So if you, for instance, use 2000 VNI, the routing table that will be used will be 2000, for instance. You have a loopback IP there, which is the loopback IP of the VRF. You have the VTEP IP, that is the termination the termination point of the VXLAN tunnel. And you have some read-only components also that get filled up by the server itself, and this is the local autonomous system. for the VRF. You have the route distinguisher, the router MAC. Those are concepts of EVPN protocol, and you have also the imported route targets for this VRF, the exported route targets, and the VLAN IDs, which is a list of the connected logical bridges to this VRF, because in the VRF you can have one or more connected logical bridges. The next service that we have here is the SVI service, and this is for management of the switch virtual interfaces that binds logical bridges to VRFs. And you have the different operations on those SVI: create, list, get, delete. And if we go to the SVI object, SVI info object, you define the name of the VRF that this SVI should be attached. You define the VLAN ID that this SVI represents, the MAC address of the SVI interface, the gateway IP, this is the IP of the SVI interface. And you have also two other fields. The first one is the enable BGP. So if we want to actually peer with another BGP item, with another BGP component through that SVI interface, we can enable that. And also when this is enabled, we can define also the remote autonomous system that we try to do BGP peering with. And I believe this is the end of the API presentation. Any comments on this L3 protobuf file?
No.
I did give comments at a high level, but I'll definitely comment back on the PR. But do we need some configuration for underlay as well, or is there an assumption that underlay is all configured? Or I mean, would this be handling both? So SVIs and all those things here really are for the secondary networks traffic, and then there is underlay configuration that is needed to be riding on top of it. So
yes, that's a very good observation, right? This is not self-contained yet.
Okay.
The underlay parts are assumed to be configured outside. So it has to be complemented with APIs to configure the lower layers of the stack, underlay routing, and also the base configuration of the routing stack, the EVPN routing stack. This is focusing on the tenant layer, the VRF layer.
Makes sense, yeah, and I think that's what I thought, yeah.
Yes. So even with the VRFs, you might be able to leverage things in OpenConfig. The network instances of the OpenConfig models actually define both EVPN as well as VRF configurations. So there may be overlap between the two, and you might be able to leverage the standard.
Yeah, good point. And I think if you look at the OpenConfig APIs for EVPN, it's probably a superset of what we are doing here.
It could be.
Yeah, I'm pretty sure it will be. It's very unlikely that we have used something that is not covered by those APIs. The issue is that these APIs are, of course, huge and complicated to use. And the question is, do we really want that?
Yeah, we'll have to dig into it deeper and take a look.
We don't have to adopt all the APIs, right? If we have models that kind of look useful for us, we can just pick those models and generate APIs from those models. We don't have to take everything.
Yeah.
At least what I'm thinking. But I do think that reinventing completely new APIs for networking is not going to do any good for anybody, because people that are going to implement those control systems like you do, or like you did in your demo, basically the clients that driving those APIs, right? If you're defining a completely new set of those are going to be proprietary for DPUs instead of using probably the same tooling that you're using in OpenConfig today in order to configure switches and other network components. So maybe we can reuse some of those, and the client's already there, and the network administrator is already familiar with that. So that's the only concern that I have.
Yeah, I think very valid comments. But if you look at, for example, one new user of this API, very limited user, it's the CNI, right? That will have to be talking to this API to set up the networking for the what we call bridgeport, which could be called interface, whatever. If that would have to implement and integrate a full client for OpenConfig, just in order to do that, to me, that is not a simple solution. Right, even though that may be a standardized API fragment, it doesn't necessarily, it's not necessarily simpler.
I agree, but instead of the full client, we can use already existing libraries in order to write the client, but at least you don't reinvent from scratch. And just to remind, yeah, we understand that Kubernetes is a very important use case, but it's not the only use case for DPUs, right?
No.
So we are envisioning a lot more use cases, not just in Kubernetes world. So everything that we build, we agree that we'll start separate. And this is why we have separate folders for cloud APIs. But I do envision once we have a little bit more maturity, we immediately start on combining those, because it doesn't make sense to have maintaining 5 different set of APIs, which defining very similar objects.
So Dan, I think you had your hand raised, but put it down. Did you had something to add or?
No, I was going to say, but what Boris said, I agree with. Yeah.
Oh, okay. All right. Any other comments?
This
Questions here?
API, I did not see BGP attributes and BGP peering definitions here. Is that included in this, or is it something that would be added later? In those 5 objects for logical bridge, bridgeport, SVI, VRF, and those things, I didn't see the BGP peer configuration and BGP local configuration. And
yeah, that's right. As we said, these parts of the configuration, the lower layers of the configuration, which is kind of global for the XPU, are not covered by those APIs.
Okay. So one last comment, I'll leave with this one, which is that this is, I was really hoping that telco APIs, we define things like how do we offload UPF functionality and or VRAN functionality and those things. I'm not saying this is not telco. Of course, this is a very much a telco use case, but this is more of a telco cloud. And then actual telco APIs would be the acceleration of the virtual functions that get implemented on those pods or containers in this. So
you mean the offload of application networking functionality onto
like
the
for example,
XPU through the virtual function in some way or the other.
Correct. So yeah, I was thinking that like deep down, that's like hardcore telco stuff, wherein how do you take UPF or VRAN functionality and start to offload that into DPUs. But this one, I understand the goal of this one is to provide the cloud for the telco services, really. So
cloud networking, EVPN based cloud networking. Yes.
Correct. Okay. I just wanted to tee into Boris's comment that this is not exactly a separate domain, which would be like UPF and all that would be a completely different domain, but this is still defining the cloud APIs for telco.
I think it's a lot more focused than that. I think this is pretty specific to your specific application, though, right? Not generic for telco.
Yeah.
That's
It's
pretty
generic. It's generic, but a specific use case.
Yeah, that's what I mean. Is that
Okay.
it can be used broadly in telco, but it does not define the APIs for telco, right? Like, just want to make sure that we have that clear.
I think
Yeah.
Vipin summarized it fairly well. It is networking, cloud networking APIs for telco use case based on EVPN gateway functionality.
Yeah. And the reason I use the term cloud here was because we will end up defining underlay for it to be fully sufficient. We will end up
Oh, yes.
defining BGP. We will end up defining other things as well. So that's why it will look closer to cloud APIs once it becomes wholesome than
Yes.
the telco APIs. Which when I say telco APIs, those are the acceleration for telco functions or VNFs or CNFs kind of things. Anyway, let's. This is good though. I think at least the use case is very clear to me.
Dan, you got your hand up?
Yeah, I wonder if we need to bring it back though and understand what is the value that we're hoping these APIs provide. Like, I think it would be valuable if, the application here invoking these APIs could invoke a standard, but, is that the benefit that we're trying to gain here? So would someone else's application be able to use these APIs for maybe a similar or even the same use case, but with a different control plane, different target? How do we ensure that beyond just the sort of the existence of the API? That's more maybe I'm taking it a couple steps too far, but I'm trying to get back to rather, I don't think we want to just like take the APIs that we're currently running with and just standardize them. I think that we're trying to get to something more broadly applicable, right?
Yes, we're trying to get to something that's more applicable. One of the early objectives that we laid out was that we want to try to use standards-based things as much as possible, because a lot of those already exist in network configuration solutions that are out there today. And if we can leverage as much as possible of that capability, we can get to an end goal solution faster. The difficulty in the networking space is that you've got telco use cases, you've got cloud use cases, you've got enterprise use cases, et cetera, et cetera. There's probably a superset that's common among them all, but then there's going to be potentially some subset of very specific operations that may be particular to a particular grouping. It might be specific to telco or specific to cloud or specific to enterprise or whatever. So that's why we're bringing up things like the open config model, or potentially leveraging some of the other ones, because we want to get to that common goal. If we can define them in these different groupings like we've been doing, and then later on massage them into something common, that's where we want to get to. Does that make sense, or did that answer what you're looking for?
Yeah, definitely.
Okay.
I also want to raise one awareness. We discussed it several times already, and recently with Vipin as well. But every time we define the APIs in OPI, what we agreed upon previously is we have to have a reference implementation which is open source that uses those API. And I can give you example that when we define the IPsec APIs, right? So we immediately have a project, OPI StrongSwan bridge, that spin ups two StrongSwan applications and uses those API in order to establish the tunnel, and then verifies that APIs are not broken and you actually can do useful stuff with it. Same for storage. We defined the SPDK, and we defined the OPI SPDK bridge, and we drive those APIs that we defined into real life open source applications that everybody can spin up and verify and test. What I encourage here is, once we have this massaged a little bit and all the reviews are being answered, I do encourage for the entire team to think what kind of open source application can be, I don't know, DPDK based or something else that can actually implement the EVPN between two endpoints, and we can drive those APIs and test them in a real open source application.
Boris, currently we are in the process of upstreaming several stuff. They are not ready yet, but we will come to that point. I mean, the API pull request that we have here is just the first step. As I said, we are developing an XPU CNI right now, which we will open source that. And in the future, we will also upstream the XPU infra manager, and we will also upstream pod definitions in order to use all those components and communicate to each other. So there are more stuff that will come in. Yeah, it's just work to be done, really.
I understand that, Dimitrios, and I'm saying that we need something more low level. Like, we don't need the entire CNI open sourced yet, right? That's will take time, and we patient with that. That's fine. But I think we need to find which kind of smaller open source application that already focusing on, for example, EVPN just tunneling between two endpoints. Maybe DPDK already does it today. So what we can do is we can just do simple translation from those protobufs to DPDK, and then I'm just throwing an idea. And then we can just test that those APIs are really useful. We can really describe something with it. And we always verify with each and every pull request that we don't break things. This was extremely useful for us so far. So while you taking your time, which is completely fine and understandable with, open source and CNI and the infra agent, that's all fine. But I do encourage us to find a very simple or well understood and known, maybe even with Linux kernel, I don't know, but something that we can spin up and use those API, translate that to some commands to this application, like we did with StrongSwan for IPsec, right?
Yeah. And Dimitris, can you bring up the slide again with our proof of concept? It's probably easiest to explain what we intend to do. Right. So most of the EVPN implementation is actually open source, right? It's the EVPN gateway, it's the FRR. We have Linux bridging and routing, and eventually we'll integrate with the StrongSwan for the IPsec control plane. But that is not really relevant for these APIs alone. So the only piece that is kind of missing here is what we call the XPU infra manager, which basically terminates the API as the API server and translates it into the equivalent configuration of Linux bridging, routing, and FRR. That we will upstream, and that won't take very long. Then the data plane implementation in Linux is there. It just works. You need to run it over. You can run it over any network interface on that XPU. And you get non-offloaded data plane immediately.
So I understand what you're saying. So the route that we took in OPI, if you look into all the GitHub repositories we implemented individual OPI bridges. So we have a separate repository for OPI IPsec StrongSwan bridge. We have separate repository for SPDK bridge for storage. So if we're doing the EVPN, I prefer us not to go with the route of XPU infra manager. But if we have EVPN already existing gateway, public existing open source, I prefer that for us to develop
a bridge.
The
what
bridge.
You call a bridge. Yes, an EVPN gateway bridge.
Exactly. EVPN
that
bridge.
is just a different name. It's just a different name for the same thing.
Yeah. Okay.
Yeah.
But then you know, the IPsec and these bridges are coexisting, and then we can put the gateway in front of it and doing gRPC load balancing. So that feels just a little bit different from this picture, but I understand what it's, yeah.
Yeah.
And what is the VPN gateway implementation? Is it kernel space, user space, containerized? Can we run? Where can we run it? I just thinking about CI/CD pipelines that we have.
Yeah, okay. That all these questions right now in our POC, it's not containerized, but it can for sure be containerized. It's just a matter of deciding what to do and how to do things. I think there we are very much open for discussion.
Yeah. If you want to, let's connect offline. We can open the repository for this bridge, even without the protobufs fully defined, because either way, we are going to define some kind of APIs for this. And I can help you already establish the CI/CD pipelines, containerize the VPN gateway, and then we can have the bridge, and then we will implement the translation once the protobufs itself is finalized. Make sense?
Yeah, what do you want to do with the bridge if you don't have the protobufs? What should it do? It won't do anything.
All the infrastructure around the protobufs, right? Because we need to have two EVPN in containerized environment talking to each other. We can configure them either manually or through, you know, kind of script right now, and then we just replace that small part with the actual gRPC server. So we have all the infrastructure for how the gRPC server looks and how they work, and then we can just replace for the specific protobuf definitions.
So you want, okay,
Infrastructure ready for the protobufs.
just to understand, you're gonna deploy the control planes that we have here in the picture, and then you're going by hand create the VPN instances without using any IFRA manager. I'm not sure that I get that.
And it is a fully simulated environment that you're talking about, right? To one
Absolutely.
server or two servers running this connected through some network interface, or you even want to see this locally on the same machine?
Yeah. And even run it in CI/CD pipelines. We're using GitHub Actions, so I would like to see all of that being spin up in Azure and running with GitHub Actions automatically. And then we'll plug into the, I don't want to call it Infra Manager, it's a EVPN bridge for me to API. So then we'll do that, and we'll plug in the protobufs. But before we can do that, we need all of this infrastructure to be up and running, either with configuration file even, right, or simple shell commands. But yes, we're using Docker Compose today to spin up containers, and this is our CI/CD pipelines as today. We can follow up offline if you want to. Just reach out to me to Slack, and we can.
And do you want to go as far as the Kubernetes control plane? Would you think that that's necessary, or is it just the low-level kind of control plane that you want to spin up?
I want a low-level control plane because this will allow different applications, not just the Kubernetes CNI, to use that. And we're just using that, you know, just to verify that this API is useful and not broken in every single pull request. So we know what we're doing and how we're enhancing that. Once you have your CNI implemented, I have absolutely no problem to discuss how we can add additional CI/CD pipeline to actually spin up a CNI, for example, and then use that to drive the same APIs. But all the infrastructure before that is already up and running.
And how do you test the data plane in your CI/CD pipeline? I mean, what kind of interfaces do you use to send and receive traffic?
For storage, for example, right, we're using NVMe over TCP. For IPsec, we're just doing ping over the tunnel, stuff like that. So we can discuss here exactly how it will look like. So that's definitely the discussion that we need to have.
Yeah. Okay.
Yeah, probably we need like some design, like some pictures, so we can actually understand the whole concept.
Because otherwise, it doesn't make sense for me to develop an open source project that cannot be tested or spin up locally. It's very difficult to have very abstract kind of thing or very CNI oriented. Not everybody interested in Kubernetes, but I think that those EVPN gateway bridge APIs are really useful for more than one use case. So ping me offline. We can have one-off meeting together, just 3 of us, 4 of us, or we can start closing this on Slack offline, whatever you prefer.
Okay. Thank you.
All right.
Sure.
So Dan, I think you had a question.
I was just going to inject really quickly is that I would think that we'd want to try to standardize the APIs underneath that infra manager, not above it, and that your IP stack looks a lot like our OPI security API. We could create an OPI sort of protobuf that sort of mimics or standardizes the EVPN gateway configuration. And, you know, I think that the cloud APIs already kind of touch on a lot on what you can do in Linux bridging and routing. So, you know, we could standardize what's underneath that infra manager a lot easier potentially, so that, you know, it would make it easy for you to port your application and your infra manager onto different systems.
The
I feel that the same argument that
No.
I disagree with Dan. I think that this is exactly the same route we already described with IPDK and 2-layer abstraction interface, and I'm really against it. So we can discuss offline as well.
Okay. Well, everyone, we are at time, or actually a little over, so I will get the notes and the recording out onto the Slack page. We'll get it up on the YouTube channel, and we'll meet again next week. Thanks, everyone.
Thank you.
Thanks, folks.
Thank
All
you.
right.
Bye-bye.